coordinates of points that are solutions to that equation. We want to graph a representation of the solutions of this particular linear equation. Now the best thing to have it is in slope-intercept form. So like these two, we know what the intercept is. We know it crosses this y-axis right at 4. We know its slope is going to be 3/1. It's going to start to rise and run at that constant rate. We can also see equations that are in this point slope form. And to graph them, there's a couple ways that you can do this. The first way is you can find out what is the point that is being used in this equation, and we can use that point as kind of a starting point when we look at graphing our solutions. So there's our point slope form. The slope is going to be this 1/3, that number that's right in front of my parentheses. And then the point is the y1 and x1 in my equation. So the y minus y1, that 3, that y minus 3, that 3 represents the y coordinate of a point that is on the line. And then the x minus 3, this 3 also represents the x coordinate of a point on the line. It just so happens to be, it's just an anomaly that this one, the x and y coordinate are exactly the same. So the first way we could do this is we could find the point that is in the point slope form equation. So 3, 3 is representing a point that's on the line. That's one of my solutions. Now one thing that we need to keep in mind is that y minus 3, x minus 3, we kind of have to think of that as that 3 is like the opposite. So if it's a y minus 3, that's actually a positive 3. X minus 3, that's actually a positive 3 for my x and y coordinates. So now I would go to my graph and I would graph my point 3, 3. Now this is different than slope-intercept form. Slope-intercept form, I always start on the y-axis and then go from there. Point slope form, I'm going to start at that point and then I can use the slope now to find the other solutions. And I'll do that right now. So I'll start at this 3, 3. My slope is 1/3, which means I rise 1, run 3. So let me put that as well. Rise 1, run 3. And I usually like to just put as many as I can until I run out of room. We'll head back down this way. And that's about as far as we can go. So there's my line that goes to the point 3, 3. And it's going to rise and run at a slope of 1/3. That's one way that we can take a look at that type of problem. Now I'm going to erase this, and then we'll look at another way that we can work with this point slope form. Next is you can simplify your point slope form back into slope-intercept if you want to. It only takes a couple of pretty simple algebra steps. This 1/3 right here, I'm going to take that and I'm going to hand it out. What property am I using to hand out that 1/3? What are we using? Not substitution. When we hand something out, we're distributing, so we can use that distributive property. What that's going to do in algebra, what distributive property is used a lot, is gets rid of those parentheses. All right, so now we've got y minus 3 equals 1/3 x. Now 1/3 times 3 is just going to be 1, so it would be minus 1. Now it's not quite in slope-intercept form. If you're looking at slope-intercept form, the one thing you have to do is you have to get the y solved out. So y is not solved out. I still got a minus 3, so I'll add 3. I'll add 3. So I'm going to have a y equals 1/3 x plus 2. Now maybe you noticed as I was drawing the slope the last time, I was crossing the y-axis right at 2. That's what was happening. But in any case, my m is going to be 1/3. My b is going to be 2, which I don't like writing it like that. Your b is actually going to be the y-intercept 0, 2. There it is. And we've already graphed it, but that's going to be another way that you can graph those solutions. So if you wanted to, you can take your point slope form, you can just do a couple little algebra moves to it, and you can get it back into slope-intercept. So a skill as you get into algebra 2 that we're going to use quite a bit. So we start in point slope, and then we get into slope intercept. And if you have aspirations of getting to pre-calculus someday, actually no, I was walking by Mr. Spike's room the other day, and they were talking about this exact same stuff. They were talking about point slope form and converting it back into slope intercept. So that will be something that you will use as you continue your math careers. So that was number 7. A couple ways you can graph it. You can kind of choose how you want. If you want to start with the point in the point slope, you can, or if you want to convert it into slope intercept, that's totally up to you. You can use either method. The other thing I want to talk about from 3.7 was the special cases with the x equals and the y equals. So these can get a little tricky as well, trying to navigate, because we're so used to seeing a y and an x. So now, why don't we just have an x equals, a y equals? So x equals -4. We're going to have, when we have an x equals equation, that means my x coordinates are all -4. So if you go to points where x coordinates are -4, 0, or -4, 0, excuse me, -4, 2, -4, 4, we're going to start to see a vertical line. So x equals -4 is going to be a vertical line where all your x coordinates are -4. Y equals 6, same idea. If you just have a single equation, y coordinates are all going to equal 6. So we go to where y is 6, 0, 6, 2, 6, 4, 6, 6, 6. There's where we're going to see all of our y coordinates are going to be equal to 6. We get a horizontal line. So you have an x equals equations, y equals equations. Sometimes we see that and we think, oh, we can't graph it. It doesn't have a slope, doesn't have a y-intercept. Well, those are representing to us the coordinates. So all the x coordinates, all the y coordinates have to be the same number when we're looking at those things. So just a couple things then from reviewing linear equations in section 7. All right. Section 8. Are there any questions we had from section 8 that we would like to take a look at? Anything? Well, the big idea in section 8 is to be parallel, your two lines are going to have the exact same slope. And to be perpendicular, they're going to need to have the opposite reciprocal slope. So if we look at 10 and 11, just looking at a little bit of algebra, or actually we're going to look at 10 is neither. So we don't need to worry about that one. That one's going to be neither parallel or perpendicular. But parallel means your slopes are the same. And perpendicular means your slopes are opposite reciprocals. Oop. Okay. And one thing that we didn't do section 4, but perpendicular. So the parallel symbol, we've talked about the parallel symbol. Parallel, you have these like two long lines to represent parallel. Perpendicular, you may start seeing this. It's an upside down T. So perpendicular, when we see this upside down T, that's going to be perpendicular. So we have a line coming, hitting at 90 degrees. That's going to represent our perpendicular. So we'll see those symbols coming up here when we're starting to talk about parallel and perpendicular. All right, so let's take a look then at 11 and see what type of slopes we have. So let's review how we can change these equations into slope-intercept form. So right now, when we have an equation that's got both the x and the y on the same side, this is called standard form. We can't tell what the slope is, so we have to solve it for the variable y. Once we get it solved out for y, it's in slope-intercept. Now we can start to to see the slope. And it just takes 2 steps to solve it. So we got a 3x plus 4y equals 12. The first step you're always going to do is get the x moved over to the other side. So we don't want the x and the y on the same side. Let's get them on opposite sides. And there's what we'd have left. So we got the x and the y terms now on opposite sides of the equal side. So your first step is always going to be if the x and y are on the same side, get them moved so that they're on opposite sides. And if you have anything with the y, you want to get that moved to the other side. So 4y now is alone on the one side. Next thing we'll do is we'll divide everything by 4. Divide by 4, divide by 4, divide by 4. And the only thing that you're worried about are the slopes right here, this number in front of the x. So I look at this number, -3/4. Is there anything I can do to simplify that any further? Nothing. So that's my slope of that particular line. So the first line, I'm just going to make a note up here. The first line has a slope of -3/4. So there's going to be my first slope. Next, I'm running out of room, so we'll have to go over here. 6x plus 2y equals 6. So we'll get the 6x subtracted over. We'll get 2y equals -6x plus 6. Divide everything by 2. And we take a look at y equals, then we got -6 over 2, which our m is going to equal -3. So looking at them, obviously, are these two the same slope? No, definitely not the same slope. Are they opposite reciprocal slopes? No, because they're both negative, plus they're not reciprocals, 3/4 and 3. So this one would be neither. So that one is neither as well. And I screwed up by just realizing that that was the one that was neither. I thought 10 was 10. All you have to do to get in slope-intercept form is add this x over. Then we get y equals x plus 20. So this one has a slope of -1. This one has a slope of 1, which those are opposite reciprocals. So this one should have been perpendicular. My fault on that one. I was thinking about the wrong problem there. So that one would be perpendicular. This one would be neither. And it looks like the last one would probably be parallel. So you can solve that one on your own. See if they're the same. So we get one of each there. But to get it into slope-intercept form, we're just going to get the x and y on opposite sides, divide by that y term, and then all you're focused on is what is that slope in front of the x. You really don't even need to complete the problem. You're just looking at how do I get that slope, get that number in front of the x, and then I'm set to go. So that was looking at section 8, kind of reviewing some more algebra 1, looking at how parallel perpendicular lines are. We'll leave it right there. I'm going to go get the rest of those copies so I can get those out to you. I'll leave this up here. If you need help with those other ones we did on 3.7, if you didn't get a chance to get those, sorry with the printer being a little finicky. But the rest of the time then is yours. I'll come around to help individually with any problems you have. And like I said, the keys will be done by today. So you can go back and check in the folders. They'll be ready. All right, so I had a couple more reviews. Any other that needed a review? Review. Numbers. You can use either one. I would just pick numbers that are smaller. Okay. All right, then we needed the 3.8 and 3.7 too. There we go. 3.8 and 3.7. Do that. There we go. Any other 3.8, 3.7s? Three, 3.7. Any other 3.8, 3.7s? Yep.